In this video, we'll create a shader which mixes the colors back and forth over time, and that shader will be applied to make this glow. You need to install Unity 2019.1 or above with a Universal Render Pipeline. Before we begin, you should grab this beautiful model, which is created by Rai42 from the inspiration of the famous movie Tron Legacy. Some textures need to be pre-processed before importing to Unity. You could do it yourself or download the processed textures from my Patreon page. So, let's take a look at the core idea of this shader first. Imagine that we had two colors and we could mix or blend them together with a ratio. When a color is put more than the other to the mix, it would contribute more to the final color. The mixing factor closer to the left means that the first color contributes more, and when it is closer to the right, it means that the second color contributes more. In shader, we use a range of 0 to 1, which is equivalent to 0% to 100%, to express the mixing factors of the colors. In order to change the color over time, we just need to update the mixing factor T from 0 to 1 and then reverse the direction. Keep repeating this process. We could create the glowing effect we want. This is a challenge for you. Could you create a final shader just based on this diagram? These are the steps needed to achieve the result we want. Firstly, we will create a new shader graph, and then we will create a material associated with the new shader graph. And these two first steps should be done by yourself. The next step is assigning material to the disk. After that, we will create two color properties to mix them together. And finally, we will adjust mixing factor 3 times. Here comes the first step: create a new shader graph. In the project folder of Unity, click Create button and then select Shader P-Bar Graph. Give it a name like Glow. You can double click the shader graph to open it, and you will see there is a node inside, which is P-Bar Master Node. You should create a new folder to store this shader graph assets. There are two types of folder structure for easier management. The first structure is you create a new folder for each asset type, like a separated folder for shaders, and then another one for material, another one for all the textures. And the second structure is you create a single folder for all the related sub-assets, no matter what types they are. Like you put everything of a character inside a single folder, including the mesh, the models, the animation, the texture, everything. You could find the folder structure that suits your need, but it's better to stick with one. Now let's move to the second step: create a new material. Firstly, select the shader graph asset and then right-click, Create Material. Moreover, you could see that the shader of this material is assigned automatically. Then give it a name like Glow underscore Tron Disk-like underscore matte. Matte stands for material. Think about how you will search or filter for it later. You might end up with what's called a professional naming convention, but with your own rules. In the next step, I will assign materials to the disk. The disk uses two materials, one for the body, which is a dark part, and another for the glowing blade part. For the body, we could use a standard list shader which provides PBR textures. For the blade, we will use our custom material. Set up your own scene with camera, lines, and material for the disk. Now that you are all set up and ready to go, from now on, any changes of the shader graph could be observed directly in the scene. Let's create two color properties. I've mentioned about the relationship between the port and the data type previously in the NURD section. Now it's time to introduce some data types to you. Shader graph has several data types, and we'll take a look at some of them. The first one is a number. Vector 1 is just a single number. Vector 2 is a pair of two numbers. Vector 3 and Vector 4 are just sets of 3 and 4 numbers. A slider is just a single number which is limited in a range. If you are a programmer, you'll find the type integer and float familiar. There's nothing fancy about the numbers. Numbers are just numbers. So let's move on to the other data types, like the color. The color types is used to define a color in RGBA format, and a gradient type is used to define a gradient between colors. You cannot adjust it outside of the shader graph, at least for now. The last one I want to talk about is the texture. The texture is used to define the texture to be sample. Among them, color is truly a special one. It's actually a vector 4. Surprise? A color data is packed in 4 channels: red, green, blue, and alpha. Each channel could be represented by a number in the range from 0 to 255, or FF in hexadecimal format. In shaders, these numbers are mapped to the range of 0 to 1. Then, a color is just a set of 4 numbers between 0 and 1. That's why a color type is compatible with a vector 4 type. Zoom in and you'll see ports with each data type having different colors. Do you notice that vector 4 and color type share the same colors? Ports with the same color are compatible. Moreover, all the number types are compatible through the promoting and truncating mechanics. You could find more details about the data types on the shader graph manual page, and I provide the link to this page in the description. Now we know much more about the data type and especially the color. Let's create 2 color properties in the shader graph. Select a blank spot and right-click, create node, color. Repeat the step to create the second color. And then you can adjust colors as you want. If you try connecting one of those colors to the Albedo port in the master node and click Save Asset button, you would notice that the color of the blade in the scene changes accordingly, and that's how shader graph works. Nodes adjust medium to provide values for the master port, and the changes happen almost instantly. Awesome! Let's move to the next step. As long as the color is just a 4-dimensional vector, the mixing operation is just a mask function. Values in each pair of channels, including red, green, blue, and alpha, are calculated follow the formula of linear interpolation, as shown on the screen, with A and B are the numbers of each pair, and T is the mixing factor of B. Don't worry, you don't have to do the math. Shader graph has a node to calculate this formula called LOVE. Let's use this to mix the colors. Firstly, create a LOVE node to mix the values, and then set the colors as the values you want to mix. This means that you should connect 2 colors to the A and B part of the LOVE node. Then we need a number to control the mixing factor. The choices we have are vector 1 and slider. In this situation, we want to climb the range of the mixing factor from 0 to 1. That's why I choose a slider. Finally, set the LOVE output as Albedo in the master node and click Save button. You can play with the slider to adjust the mixing ratio. And in the next step, we just need to let time control this number. Time is just the number of seconds passed from the first day of 1970. So the range of time values is huge, if not infinite. On the other side, our mixing factor value range is very limited. So, with the intention of converting time into the mixing factor, we must find a function which transforms any number to another number in a fixed range. There are many functions like that, but I will pick the sine function. Why? It transforms x to a number in the range of -1 to 1, which creates infinite loops. Look at the graph. The sine wave is so smooth, which is ideal for applying easing to the motion. Let's use it. Firstly, create a time node, then set the sine time part as the mixing factor in the LOVE node. That's it. Lean back and enjoy watching your colors are mixed automatically over time. Wait, something wrong. The first color seems to appear longer than the second one. In order to debug these issues, I'll try to simulate the sine values by connecting a slider with the range of -1 to 1, and we'll see how LOVE node changes when we change the slider value. And there it is, I find the first clue. All the negative values lead to the first colors as a mixing result. It means that there's something behind the LOVE node. By referencing the shader graph menu page, I find out that the mixing factor is claimed to the range of 0 to 1. It means that all the numbers outside of this range will be forced to take the nearest numbers. In this case, psi function produces results in the range from -1 to 1, not from 0 to 1 as we want the mixing factor to be. All negative values are clamped to 0, and this explains why the first color appears longer than the second one. In order to fix this, we just need to scale the range from -1 to 1 into 0 to 1, so that any value in the range of -1 to 1 could be mapped to new values according to the ratio in the range of 0 to 1. This could be achieved by remapping. In Shadow Graph, create a remap node and set psi time as the input to be remapped. Other parameters of the remap node are already set up to scale -1,1 to 0,1, so leave as they are. Finally, set remap output as the mixing factor, and that's it. Congratulations, you've reached the 100% completion level of this task. The two colors are fixed inside the shadow graph. Let's make them customizable by using the blackboard.